to take recordings on Mac. Like I sent it on the chat if it might be useful.
I've started the
Okay.
screen recording.
Okay, fine.
This is what Parul was saying. She's using the same thing, correct?
Okay.
Okay.
Thank you.
Yeah, now you can start.
All right. So, hello everyone. Good evening. Thank you for finding time on a Monday night, just one day before a holiday. Welcome to the session on Dockers in long pending. So before we get into this, you guys can see my screen. I hope I am audible. Please let me know. Please feel free to stop me anywhere where you are unable to understand anything, and we'll take it up. So when we say Dockers, it's like talking about toothpaste and someone saying Pepsodent. So there are other Colgate, other Cibaca available in the market. So Docker is just one of those which depends on a technology called containerization. So why this? Now, whenever you develop an app in isolation, what happens is, let's say your app uses certain libraries, 2, 3 libraries, and let's say you're on a Windows system, and I have a Mac. Now, to have the same app working on my local, you have to give me like a write up that, hey, install this, install that, but it takes time. Now, when you containerize any application that you have built, or like you want to share it across someone, if you just package it as a Docker or any container for that matter, we will see that you can. I'm not saying that it will be directly be working on Mac, but let's say you have because Mac has chips and everything. We'll not go into that. But let's say you share it with another friend. They don't have to install anything; just run it, and the application comes up on their web browser if it's a web browser application or anything like that. So if you very closely, this is a very old Docker logo. The reason why I have put this is because first thing is looks nice. Second thing, if you see, is this is exactly what this does. If you have seen container ships, like pictures of container ships, you've seen that ship carrying loads and loads of 20 by 20 feet container, 20 by 10 feet container. I mean, so that is exactly what Docker does. If you can imagine, each of this is a dependency for the application, and this is the entire application. The other alternatives that a lot of competitors that have come into market, they're catching up as well. One of them is Podman, the other is Containerd, etc. Personally, I haven't used any of them, but I have used Dockers for quite a while now. And so imagine this as a basic container for your application. It's like a bowl for your soup. So now, it was not like that, Dockers came into prominence in 2013, 2014 type time, maybe a bit earlier, but yeah. But before that, people also had the same problem. So there was this concept of virtual machines, and I'm sure a lot of us know about virtual machines. A lot of us have used virtual machines. I remember that one of the primary use cases for engineering students to use virtual machines was when they, they had a Windows laptop, but they wanted to run Ubuntu. So they would say always run Ubuntu VM. So that's the virtual machine I'm talking about. Now, before Docker was in prominence, and also a lot of application till date still use virtual machines as a way of packaging. Like what happens is, let's say you want to send certain applications, which is your proprietary application. What you do is you put all those applications in a virtual machine. Basically, it's like sending one computer to another person's system, and they just run the virtual machines. So you have your host machine, which is your computer. On top of it resides the virtual machine where it works. The reason why I have put virtual machine in this presentation is because we need to understand the difference between virtual machines and Docker. Now, virtual machine is the emulation of a physical computer within a host machine. Why is emulation important? There are two words in English: emulation and simulation. Emulation is when simulation is basically when you mimic the environment only and nothing else. Emulation is, you might have heard about Android emulators. The reason, because it also mimics the software behavior plus the underlying hardware capability. That's how the VM operates. So you basically, whenever you package and send a VM, the person will have an Ubuntu machine on their system. It will absolutely behave like Ubuntu. There will be no trace of it being a Windows thing. And when I said that VMs are actually isolated. There are ways that you bridge those gap, and like you create a network where both can interact. You can copy files from one system to another. All of that works, but essentially VMs are isolated. The networking part is optional, and you can run any uh, which is a non-Windows software. One prominent non-Windows software which I had used during my time of using VM was Vine, which was a media player for all the MP3, MP4 formats that was available then. VM is very good for testing. Like, why do we still use it? It's very good for testing. Like you send, and a lot of big companies still use it. Amazon uses it. They also have their own VM hosting services. So that could actually tell you that VMs are still popular. It's not obsolete. We still need to understand what VMs are and how do they operate. As they run on the OS weather side. You basically install something called a virtual box or a VMware something, uh, and that library is essentially a hypervisor over the host OS. Now, hypervisor is a piece of software that enables the VM to mimic the behavior of the guest OS that it has, like Ubuntu, for example. And if your computer is resource intensive enough, you can host multiple VMs. There is a picture here, uh, and this is exactly how it works. Your hardware, whichever is, let's say, i7 or a Mac, you have your host operating system, Windows or a Mac OS. You have a hypervisor, which is what you install. Basically, VirtualBox used to be open source, not anymore. But yeah, it's still available though. And that is that library that you install. And on that library, you run a VM image. Inside your VMs, you can have apps. You can interact with those applications either by logging into the VM directly or you can, on your host OS, you can access these applications, as I said, over a bridge network. So the out of everything, the most important part you need to focus on is the hypervisor, because when we move into Dockers, you will see the difference. Now, as I said, Dockers works on containerization technology, a portable unit of software where you package in everything that is one and you sail the ship in the ocean. And unlike a VM, I'm sure you understand that when your VM comes up, it boots up the host OS. It takes a bit of time, but it's not with Dockers. Dockers work just atop the guest OS. And the similar diagram for a Docker is like this. You have hardware host operating system, which was common. Instead of the hypervisor, you have a container engine. Now, this container engine is the most popular one. Since we are talking about Dockers, it's called a Docker engine. And on top of that, you run your containers. The reason I'm saying containers now is because we will start using these terms, and I'll go through the jargons that I'll use in this presentation. Are we okay? We have, I'll just summarize the discussion between Docker and VM. You have a host OS. In a VM, you have a hypervisor, which enables the host with guest OS to mimic the behavior that it wants and runs the app inside it. Whereas in a Docker, you have a Docker engine, which works right on top of host OS, basically a lightweight, thin library. And that is where you run your containers. I'll get into more details. There are like tons of it. I have covered each of these differences in while I've been talking. So do you have any questions between VMs, Dockers, anywhere where I could clarify more? Just feel free to interrupt. Now, okay, so I'll get into what Dockers are. But before that, there are 2-3 things, and that I would call jargons for Docker development, and we'll go through that. Dockers are literally very lightweight. When I'm saying lightweight compared to the VM, we'll see about that, how sizes are. It's easy to replicate because, like as I said, someone builds an application on Windows, packages it, gives it to me, I can run it on Mac or on Ubuntu, it works. You can run on multiple of them on one machine. For example, one of the most important things that a lot of big companies do is they run redundant. What I mean by that is there is always a backup system available in case the primary goes down. This is because that, let's say, let's say Razor Pay as a payment gateway, you're making a payment. Something happens on the primary server and the server stops. What happens? There would be other servers on that network which will take your load and make your transaction go through. So let's say you want to, you want to learn that thing. You want to see how it works. Ideally, if I take you 15 years back, you would have had two machines or two VMs on your system. To run VMs is resource intensive. We have seen that. VMs are also heavy. So basically, it loads onto your RAM. So your RAM has to be capable enough. And to get that entire system working, to see how highly available redundant system works, you would have to have two VMs or two physical machines, connect them over a network, test this scenario out. But with Docker, what we can do is very easily, I can get the smallest of image, create that system, and test anything that I want, replication or any error scenarios, anything. So that's the reason, like Docker can create a small with a small footprint. It can create a large environment right on your system. And I'm not saying that you can create it on your phone. I'm just saying that your system has to be capable enough to handle those Dockers, which is very much possible, unlike VMs. Just imagine this scenario. It does not come up in real life, but I'm sure when you get into work, this might come. These are the jargons I was talking about. Docker image, containers, volumes, host and guest. Host and guest is pretty easy to guess, I believe, because host is somewhere where you host the Docker engine. Guest is the Docker container which is running on the host. There is a difference between images and container. Now, when I say image, it's like a birth chart for a container to be created. So basically, it's like a manifest. If I can I can borrow a term from Android, it's like a manifest of how a container will be and what will happen when the container comes up. So we have words like Docker image, Docker container, Docker volumes, host and guest. I'll run through each of this again through examples, and we'll focus what is needed when. So before we get into it, when I said a birth chart, a Janampatri, the Docker file is the start of it. This is a sample Docker file. I'm not using this, but if I just look at this Docker file, this is a simple node application. I know that, because I see node colon 18. So node is the name of the Docker, 18 is Alpine. And this is being pulled from something called a Docker Hub, which is like a repository for all Dockers. And these commands, we'll use all of this in our examples. Do we have any question till now, or can I switch over to the demo? Okay.
So I had a doubt actually. So Dockers basically they're reliable over VM because they consume less memory space. Is that correct?
I didn't say reliable. I said lightweight. I mean, reliable, of course, both are. Like VMs also don't behave out of line, or Dockers don't behave out of line. So I'm just saying that they are more lightweight. Basically, if you look at any VM image, if you try to download Ubuntu 22.04 from, let's say, Oracle site, it would at least be 1.8 GB. Or 2 or maybe 4 GB. CentOS was 4 GB. CentOS 6 was 4 GB. So imagine that. But the CentOS Docker itself is 700 MB. Like the image is 700 MB. And the trim down. So there are different kinds of images. We can go through that. That's an extended topic of discussion. We can get into that. So basically, the reason why VMs are large in size is because they contain the entire library, the entire application, even though you might not use it. With Dockers, you can pick and choose. Did I, did I somewhere answer your question closely?
Yes, sir. So basically, the VM contains like the underlying, the main operating system also, as well as the window is.
Let's say if it's Windows, it's Windows. If it's Ubuntu, it's Ubuntu. Basically, it contains the entire host OS, boots up like a real computer, and acts like a real computer as well, right? Isolation for that matter. So anything that you do inside your VM does not affect your system.
Yes, sir. Got it, sir. Thank you, sir.
No problem. So one of the first things that I would want to do is, so this repo is publicly available. You guys have the link. I've created two applications for now. I've cloned the repo. It's here. You guys can see the font. Is it visible?
Yes, sir.
Perfect. So what I'll do is okay. So I'll go into app one. Let's start from here. Whatever commands I'm using is all there a part of README. I'm just copy pasting from one screen to another. So what we'll do is first thing we'll do is build the Docker. Okay. Now I spoke about images. So let's see how do I have any images? I don't have any images. This is the command that I use, Docker images. Do I have any running Dockers? Docker PS. I don't. Let me clear screen. And now since I'm in the app and I said I have a Docker file, you can see the Docker file. If you see this, I have, let me show you the Docker file first. I'll go into app one. Let's look at the Docker file first. You have a base image, which I was saying. The reason I'm using Alpine is because Alpine's image is 5 MB only. There is something called a working directory. What happens that any command that comes after this, all of it will be applicable in the app directory, and unless it is changed. So this is very simple. Start from a base image, change it's like go into this directory. So this directory, of course, is not present. I could have used my name. It will create this directory and it will copy something which is in the Docker context into this app directory. And entry point is something that is used when no command is specified to Docker. We'll come to this later. And let me show you when I say copy sample.sh, this is where the Docker file is. This is where sample.sh is. That's why you see that, you see copy sample.sh with dot. So the Docker file context starts from the place where it is. Let's go here into this. I'll clear this up and just copy the Docker build command. So this is -t is a tag. I just want to call my app as app1. I just say enter. It will download the image, which is, see, it's trying to load. Okay, it's done. All right. So it just took 3.6 seconds to build. If I wanted to just get this app on a VM, imagine, even though I'm on a 40-50 Mbps connection, it would have taken time to download the entire 1.8 GB Docker, image, run it first, put my app, shut it down, build the image. So look at the time it took. And now let's do Docker images to see, has my image been created? So it was created 29 seconds ago and it is only 7.66 MB. And I am on a Mac, which is 16 GB or 32 GB. So this is how small the Docker is. Now let's see what happens inside the Docker. So I'll just say ti run app1. So this is Docker run. These are two parameters I'm passing. I is for interactive, so it will open up a shell. In I have this is the tag that I'd use, app:/latest. So yeah, and here. So this was my script. My script was simple. It's just loop over and stop. Now let's do Docker PS. Nothing is present. Docker PS -a. Perfect. Now it said that it has exited 10 seconds ago successfully. No problems. Now let's do this. Okay. Now this was how. Now you could ask me that why did this script run exactly? It was because of the entry point statement that we had here. It just ran the script when I did not pass any command. And what do I mean by command is anything that proceeds after this. All right. Okay, one sec. Is a command. So basically, I have to just say, now I can override. Okay, never mind. Sorry. Let me do this. So it's trying to run the script every time because that is I'll just give it one more try. I was wanting to explain the doesn't run. All right. Sorry. I was trying to explain foreground run, but doesn't look like it'll happen here. We'll see. Now that all Dockers have come out, you see something as I'll just reduce the size a bit. Sorry, not this, but okay, perfect. Do you see that every Docker that has exited, I'll clear everything and return again. All of them have a name. You see Gracious Kalam, Vigilant Elbakian, Amazing Bhaskara, Hopeful Haslet. So for all of them have a name. Now, the reason why Dockers have name is because you can have multiple of them on your system and you need to be able to address or, use that name to be able to do something, get inside the Docker or, debug or something like this. Now I'll do one thing. Let me try to run something here. I'll give my app a name now. All right. I'll call it, so you see this, the name tag is present. I'll call it app1. And what happened was I ran it in a daemon mode. If you look at this command, it has a D in it. All right. And what it did, it must have exited. I'll check again here. You see app1 exited 10 seconds ago successfully. Now I'll try to run the same command again. The first thing that you see is there is already a Docker with the name of /app1 and I'm unable to create one. So what do I have to do now is basically remove this first. All right, I have removed it. Now this command will run. But this isn't something that, which is, this is the Docker is running in the background. And this is not something that you want to do often. So of course there is a way, which is, sorry, okay. The last time I had used a container ID. This time I'll use the app name. It should work. The container name I meant. Now, this thing. So now if you look at Docker ps-m to check basically if there are, so Docker ps gives you running Dockers. Docker ps- gives you everything, including dead Dockers. So, or dangling Dockers for that matter. So you see that app1 is not present because we removed it. Now let's do this. I have added --rm in this. And let's look at dead Dockers. You don't see it anymore. All right. Perfect. I'll do one thing is.
So basically you're deleting the Docker completely in this.
I'm deleting the container after its job is finished. Let me give you an example. These are very simple examples. Let me give you an example of where we would use this scenario. Imagine you have a database, some running in a production environment, and you need to take a backup every 6 hours or so. So what you could do is basically package a sample script that we saw here, right? Imagine it's a sample script which runs a command. All right. You say start backup, you run the backup command, you put it somewhere and you finish it. Correct? So now if you do not use this remove command, all right, in wherever you are running it from, you would have to execute the remove before you run the next run. So that is why this removal of Docker and the concept of Docker being a singular namespace on a system is important. So if you understand the concept of namespaces that we use in C, C++, Java, anywhere, is that it's a universal set where we have everything which is, all of them are tied together when they are in a particular system. So this name cannot be reused until it has been removed from the dead containers, basically. So I'll just clear off the dead container using this command, docker system prune -f, So it deleted containers which have exited. It removes other things and gives me my space back. You can execute docker ps-a and you will find nothing. So did I answer your question, Samrat?
Yes, sir.
Okay.
So it's like it's like for freeing up space, basically.
Yes. And also, let's say you want to reuse a name. You wanted to use Amazing Kalam again, right? So these are the reasons why you would use the cleanup. So we looked at daemon mode with the Docker running in the background. We looked at entry point, which is the base script that the Docker runs on. One thing I did not show was Docker logs and getting inside container. We can take that up in the next one. And with this, I'll move to the second application that we have. Again, similar way. Just a moment, I'll switch screens. Okay. So the second application that we have is a simple Python application, again, which is just a simple fast API which responds to a curl command. It could be anything. If you look at the source code, it's straightforward and simple. It just has two routes. One is items, the other is a base route. Uses fast API, and I just import a union. That's it. Now, the Python applications that we use in OdiaGenAI as well, we use virtual environments. That's because, again, for the matter of portability, like the same application works on all our systems without having to think about what to install and what not to. So I have my pip requirements in place, and now let's take a look at the Docker file. So you have seen that from being Alpine, I've changed it to Python 3.9. I could use Python 3.10 or 11, anything for that matter. I set a working directory. I copy the pip requirements, install it, and this is essentially the same thing that you would follow even if you're doing it for your local environment as well, even without Dockers. I copy the source code and I set something called a command. Now, there is a slight difference between entry point and command, but we'll come to that a bit later in the slide. And this is what I do. This is just runs the server on it. All right. I'll go back here and navigate to app 2. Simple Python application, which is a server. And let's say even before we do that, I'll just do one thing. I'll just source v and vpn activate. I'll just run the same application here and let's see. So I have my environment is installed. So I don't have to do anything. I just have to run this. Okay, the application startup is complete. What I'll do here is I'll copy the curl command. You see that my port application is running on port 4000. I'll just execute the base URL, which gives me a hello world that is expected. The other one will give me a dictionary, an item ID. So basically this tells me that both of my request has been served and this application works. Now let's go ahead and package this. So similar command, exactly the same. We'll use docker build -t and just give an app name and a dot. The reason I'm using dot is because I'm in the same location as the Docker file that I'm using. If you see this is where the Docker file is, app2, and that is where I am. This is a larger image. Python 3.9 is a larger image. Takes a bit of time, and you will see. So if you very closely look at the build process, you will understand that how much time it's taking, what is the number of steps it's at, and if there is any problem, be it a network error or anything that is missing, you would come to know from this. And you can see there's at least like 200 MB. Sorry, there's actually a 1 GB file. So once now that I have downloaded before this session, I had flushed the entire Docker environment in my system, and that's the reason it's taking time. But the next time onwards, when we start building, it will bring up from cache, and it won't take this long because it already has the image with itself. Okay, we're good. It's running the Python installs. Should be quick. Okay, I'm done. I think you guys can see it now. Okay, it says naming app2. Okay, I'll do this. I'll just clear my screen and say Docker images. You see this? This was 7.66 MB. This was 1.02 GB. All right. We'll not focus on the image for now. We'll do that. Let's run the Docker. Now there is one interesting thing that you will see here. Apart from the usual things that we used, which was --rm, -tid, D for daemon, and --name, which is naming the container, I've used a -p. And what does -p mean? That on the port 4000 of my Mac OS, connect the port 80 of the application. Let's take a look at the Docker file for one more time. If you look at this Docker command, it says uvcon --port 80. That means inside the Docker, the application is running on port 80. And outside of the Docker, which is the Mac OS or anywhere that you're using, it will work on 4000 port. I'll not run this now, but look at this one. When I ran the application without the Docker, outside of the Docker, I just ran it with just 4000 port because I had used the same command, which was uvcon 4000. See, instead of 80, I had used 4000. Why? Because the port 80 on my Mac is already blocked by something else. So this is one of the most important thing of Docker, which is called port forwarding. Basically, if certain port, let's say 3306 is a port that your MySQL is using on your Mac, you can have multiple MySQL servers on 3306, but not the same port of Mac. So I'll just explain this in a better way when we have this. So you could have 3 Dockers of this running. Let's do that. I can run, I can't have the same name, so I'll just modify the name as well. So this was possible, right? Now you do a Docker PS, you would see that there are 2 Dockers of the same image, 2 containers of the same image running on different ports. Now let's do the same thing. So I put a request to my 4000 port. This came up. I got a response. I'll put the same request to 4001 port. It works. So this is why I said that Docker is lightweight. Don't take me literally right now. We can fix this. And you can have multiple of them running on the same servers. So if I have to put a load balancer here and test something, I could do that on my local. I don't need to pull up AWS or get a server or get 3 physical machines wherein like I have a load balancer on top and that distributes traffic. So I can do all such scenarios right here on my local. So this is how it works. I got the result that I wanted. I got so I got what I wanted. Let's look at, I'll remove the Docker now, and let's look at something else, which is not port forwarding. So I hope port forwarding was clear, that 80 of the Docker container maps to 4000 of or 4001 of host. That's why here in my Mac, I was able to run it on 4000 and 4001. Okay, so apart from port forwarding, there is one interesting thing, which is called a volume mount. So what is a volume? A volume is essentially a shared data folder between the host and a guest host OS and a guest container. So let me create a sample directory. Okay. So it's called PMP. I'll just add a file to it. And nothing special. It's a text file. And let me run the Docker again. So I'll just, before I go inside and do anything, this was executed outside of the container is something that is written inside tmp statement txt. Okay, let's take a look at this particular command that I used to run the Docker. Till port, it's the same. One I have used is -v /pwd/tmp and /app/tmpdir. So again, in the same format as the port, this also works the same way. This is the host folder mounted onto guest folder. Now let's log into the Docker to check. Now, how do you get inside? Okay, first thing is we need to always check is if the Docker is running. It's running. So what I'll do is I'll just get inside the Docker and I'll just run an ls-la command. You see that this tmpdir has been created. It was created because we mounted the volume. Now let's get inside tmpdir and do ls. We see the statement file is present, the same line. Now let's echo something into this file. At statement.txt, 2 lines written. And let's do this. Let's exit. So now I'll go to tmp/statement.txt. You see 2 lines written, Docker ps. Now let me remove the Docker. All right. ls-la, tmp directory still exists. tmp/. So why would you use Docker volumes? Is imagine a database. So if you write anything to a database, and let's say you have to restart your container because you are restarting the machine or something, you do not want to lose your data. So that is where this comes in. Now the next time this comes up, the same Docker comes up with this mount, and you log into inside. You just go inside the Docker. You would see 2 lines of code. I mean, sorry, 2 lines of text. Right? So if your data was, if you are mounting a volume which is like understood by the container, let's say a MySQL container, it would exactly serve the same data that you had before. This is called volume mounting. I hope this demo was clear. I'm sure you will find a lot better usage than this simple example. Now there is something which is a bit advanced, but let's take a look at the images that we built. We built app 1 and app 2, one of them being 7.66 MB, but the other was 1.02 GB. Now, given this size, do you think if I have a 16 GB system, can I run 50 containers? But if I have 7 MB size or 100 MB size or even 200 MB size, I can run 15 containers on a 8 GB system as well. Let's see what we can do about it. Docker at least 4 or 5 years after their inception, they came up with a concept called a multi-stage build. And that is what we look at today. So if you see app 2 has 2 Docker files with a different name. This is the standard naming of a Docker file. This is something that I have named it. Now, whenever we are using a Docker build command, we never, yes, please. Okay, sorry, I thought I had a question. So whenever we're using a Docker build command, which is, let's take a look at a Docker build command, Docker build -t app2 dot. We never specified the Docker file name. That's because Docker file with a capital D is the default file name it will take. Whereas even in the same folder, app2, I had Docker multi-stage, but this was not taken. So now let's look at this first, what happens. this essentially has the same configuration from line 5 to 11, which you saw in the previous one, except for two lines. And I'm using two different things. You guys can see this. So what I'm doing is I'm separating the one where we install the virtual environment libraries from the final package that we are making. So I'm using Python 3.9 Slim. If you remember, we are using Python 3.9 in the previous one. I'm using hyphen Slim, which is a even more trimmed down version than what we have. I'm copying pip requirements. I'm installing in this. This is one stage. Then I'm creating another stage. I'm copying from the previous stage the root local directory, because that is where pip installs the libraries, into the second stage and just exposing them. That's it. Now, how do we run this? The command that we use to run is here, and I'm pasting. You see this? The previous command was just build app2. I have added this, and I've just changed the tag so that we can see the difference. It's just a hyphen name and file name. Now let's see this. This will take even less time. That took around 200 seconds, but this will take less time because it is also building on the 3.9 cache. And also 3.9 Slim is a even slimmer size that I can show. All right, done. This is still building state. Okay, we're done. We're done in like 15 seconds, less than 15 seconds, I believe. Okay, now let's see how far have we come. App 2 was 1.02 GB. App 2 multi-stage is just 179 MB. And isn't this like 600 odd percentage of reduction? Like 500 odd. So this is one advantage that we have with multi-stage build. There is no change in how the app operates. So, like you can just kick this up with the same thing. I'll not mount a volume, of course. It's the same. So no change. And I'll just say hello world. That's it. So you were running a 1.02 GB image versus you're running a 180 MB image, 179 MB image to the same effect. Now I can have multiple of this on on a small system without overloading the system itself. All right, I'll go back to the presentation for a quick recap of what we got into this. We saw port forwarding, we saw volume mount, we saw running an application for a longer duration, basically a server which is running for a longer duration. We were looking at entering inside a Docker container, a command versus entry point. This I did not touch upon because I couldn't demo something, but this here, it is listed here in point number 5 for you to take a look, and multi-stage build. So yeah, guys, that was everything that I had. Did you have any question around do we have any questions or anywhere where I can just clarify anything further? Hello?
Yes, sir.
Yes, thank God. I thought I was disconnected. Cool. You please, do you have any questions?
Sir, actually, it's just an observation of mine, but I kind of found like similarities between this and what you explained in Git, like in the sense that the images are somewhat like the projects which we push into Git, but I'm not sure if that's a correct way of framing it.
So let's say Git is where your application resides, and Git is a code repository. But let's say you want to deploy the application somewhere, or hand it over to someone, you definitely need to package it. In simple terms, let's say a Java application is packed as a jar. to distribute a desktop application, it's always a DMG in Mac, it's an EXE. So these are all packages that you can help distribute. So Docker is just one such medium to distribute. They need a Docker engine to run it.
Okay, got it, sir.
All right. Any questions? Parul, you could stop recording. Thank you so much.